to this webinar, Safety and Quality of Additive-Free Foods, Technologies, Ingredients, Shelf Life and Packaging. First of all, I would like to thank Professor Mina Ciampella for this intervention and for the course that was made last March, because she is the scientific director of the Congress. I would also like to thank all of the participants who are attending today, and also the 100 participants connected remotely from all over Italy. Thank you to IPACHIMA, and the other companies that have contributed to the organization of this day. I give the floor to Erika, who will introduce you the speakers and the agenda for this afternoon together. Thank you for those who are here present and also who are online. First speaker, Professor Omodei Marco Salè, Innovation Manager at CSQA Certification, UniPDR 57 of 2019. Welcome to Professor Salè. We are ready, we can hear you well. Good afternoon. Thank you for this introduction. I will try briefly to present you a new benchmark document that allows us to present in an objective way this scenario. And I will start first outlining this document, and also will share the application, the objectives, the certification procedure, the advantages of the certification. Of course, everything is referred to this practice, which was started thanks to the contribution of UNI and ACQ, Associazione Consumatori Utenti. These are not regulations, but this is a collection of practices, of best practice, and they follow an approval procedure that is much more slim and streamlined compared to the regulations we are all aware. The reason being that we want to have a tool that could then give rise to a legal document to get immediate and timely responses to a given market need. What are the drivers that have led to the development of this practice and that can be considered as the strengths through which we can promote through the stakeholders the certification? First and foremost, sectorial associations that have been a partner in the drawing up of this practice, but also consumers themselves are concerned by this type of certification, because from a practical and emotional viewpoint, additive-free claim is a claim that consumers, and especially modern consumers, require. They want short chains, not too processed products. So this practice is aimed at achieving these objectives. But of course, this practice can also be very useful to implement national and European projects, and retailers in particular could also be interested in these projects. And last driver, but not least important, this practice could be a useful and interesting tool to combine all those corporate sustainable initiatives in the agri-food industry. What you see on the screen is very well known. We all know the 2030 Agenda and the 17 Sustainable Development Goals of the United Nations. So, of course, our practice fits perfectly well within these two frames because it would combine two Sustainable Development Goals. One, that is fair distribution of food, because additives, together with other innovative ingredients, have been added to stimulate consumers' palate without having a need for that. So this practice would for sure indirectly aim at this goal. And the second goal is the UN goal related to health and well-being. So the consumer's perception is more in need for having healthy foods free from additives or additional substances. In the frame of sustainability, there is a rule that you probably know for corporate sustainable development within ISO 26030. It is the adoption of the ISO standard 26000, which is, and I read it in the chapter 472, the need for producing an honest communication based on scientific data. So if I want to state a claim additive-free, then I need to use the information I have at my disposal to support objectively this claim. But let's now try to get to the core of the practice, that is to say, the mechanism underpinning it. And let's start with its field of application. So this practice defines the management modalities to support the production of additive-free food and beverage. It does not apply, and you see that doesn't is in capital letter. It doesn't apply to the products which by law do not require additives. And I will explain you why later, because this practice follows the same product certification approach. These certifications have to show the added value pre-requirements, which goes beyond what is required by law. This practice includes some indications as how to apply analytical tests, and also defines the scientific activities. The objectives are four. One of the first, most important one is to promote technological innovations. So how to reduce the complexity of the foodstuff and to reduce as much as possible additives, then to raise awareness among consumers, and of course increase the professionalism, the transparency of the stakeholders along the supply chain. This practice has a very sound approach, and it is also quite expensive if it has to be certified and applied. It is a product certification, and it requires a management system to support the claim, because when we carry out verifications, we need to be certain that the conditions of the product, so the lacking of additives, are maintained over the time. And this is the corporate management quality system that supports the additive-free claim. And then there is also the most important part of this practice, that is the risk management with its related activities. And of course, this has to be applied to the whole supply chain. There is a control plan, a process of traceability of the product, and then another interesting point, it is important also to consider the packaging because of cross-contamination or because of other reasons. Even with a little influence, it could cause and change the conditions of a product. And I have some slides to explain you this in practice. It might sound weird, but if you want to start such a project to support this claim, it is important to assess all the product ingredients that needs to be certified. And here you find an example of one food product. So it's the stuffing of a tortellino. So you have the fresh dough and some ingredients for the stuffing. If you consider these ingredients for like ham, mortadella or raw ham, starting from potatoes and the aroma of ham, there is a long list of additives that are used. There is one exception to this, lysozyme, and another additive that is not mentioned here, because in the former case, it is required by law, and so this is an exception, but the other additives are excluded. So in this case, I could not certify this product if the ingredients are not changed. What is therefore required is a technological change and a change in the recipe. The technologies will be then covered by the foreign speakers, and I'm sure that they will analyze this exhaustively. But of course, we need to certify if the risk mapping has been done, the risk within production processes. You see now the recipe has been changed. So DOP Parmesan cheese or grated bread have been added in the recipe. But it is also important to extend the risk analysis all over the supply chain, because cross-contamination caused by suppliers is something that can be harmful, that can actually occur. As concerns the procedure of certification, if you master this field, you know that the verification of the documentation is done at first. This is followed by verification of the certification with risk assessment, supplier management, analytical tests. And we also take some samples and we carry out analytical analysis to verify the lack of additives. If the outcome of the inspection is successful and the documentations are correct, then a certificate is issued, and of course there are annual periodical tests to verify that the conditions are still in place for the certification to be valid. Considering the approach and the method, I explain you the procedure. So the traceability is done through some samples. The company applying for the certification will be verified. If there are different plants, a sample of the plants will be assessed, the square root of the plants and the square root of the staff working in the company and the suppliers as well. Of course, not all the suppliers will be verified, but by sample, the certification body will assess some of them for those who are at risk. This has to do with the analytical part. I won't detail too much on the analysis, but of course, say the analyses are done on the finished product, on the plants and on the raw materials that might be at risk. And I would now conclude by stressing the strengths and the weaknesses of this practice. Of course, the first strength, as I said at the beginning of my speech, is related to the fact that with the certification, the company can state that its products are free from additives. From a technical viewpoint, there can be some joint audits with food safety or other similar schemes. Stakeholders are guaranteed a concrete approach to sustainability, among which far-sighted initiatives. We introduce the check on food fraud, and of course we improve the quality and safety of our products. As far as the weaknesses are concerned, technology needs to be mentioned because in some cases recipes needs to be reformulated. And the second weakness is something related to small companies, because consumers need to understand the scope of this initiative, its value. Thank you for your attention. Of course, if there are questions, you find my contact emails, and as I said to the organizers, unfortunately, I need to leave this meeting because there is another meeting I am involved in. So, thank you very much for your attention, and I will be here for another couple of minutes. And in case you have questions, write them to me. Thank you, Mr. Salè, and thank you for the outline of the certification of this practice. So, because he needs to leave us, we continue with the next presentation of the day, use of replacement physical treatments to the use of additives in meat-based foodstuffs. Professor Davide Barbanti, Associate Professor in Food Science and Technology, Department of Food and Pharma Science, University of Parma.
Thank you, good afternoon. I hope you can hear me well. So, now I would like to start by sharing my screen to show you my presentation. Okay, perfect. I hope you can see my presentation. Well, I to greet all participants physically with you over there, and all that are connected online, As myself, for personal reasons and some medical examinations, I didn't have the opportunity to join you in person. But I have to say that the opportunity of being connected online is actually changing in a very positive way, according to my opinion. The way you can move or not move around, but still participating to important events such this one. So I like to continue from the presentation by Professor Omodei Salè, because I was asked to talk about physical treatments as a replacement of the use of meat-based food. And so I'll show you some examples related to meat, but also other examples related to fish products. This is not a simple topic, I have to say. As Mr. Salè introduced, for the aspects related to the certification, we are right now in a condition, and I have to say we are, as a working group at the university, where we have plenty of applied research relationships with businesses and companies, Italian ones and also foreign ones. So we always have the initial relationship that goes through the requirement and request by companies to prepare new products, innovative products, and so on. But as Mr. Salè was saying, vis-a-vis some products are so complex from a certain point of view that it is not that easy and immediate and rapid to replace additives in those products in particular. There is an underlying trend recently that I have seen in the last 2-3 years to go towards the direction of having food products that are more and more similar to fresh products or just made products, but with a shelf life that is very long. Just to use a non very technical statement, I like to say that maybe the blanket is too short. So it's not possible to have the advantage of a fresh product or similar to the culinary products with a 20, 30, 40 days shelf life. So this creates a mechanism according to which the use of additives so far in some cases was inevitable. There are some examples, and Mr. Omodei Salè has touched on some of these. The use of nitrates and nitrites can be criticized because we know that these substances can have some consequences on the health of people, but we are in the condition where these additives actually offer a very high level of food safety. And by this, I mean hygiene and healthy aspects. So these are substances that cannot so easily replace. The second point is that replacing additives starts from the point of view of rethinking of that product completely. You will see some aspects in my following slides, part 2, planning of food processes, and then I'll show you some combinations specifically for meat-based products or fish products, where we can actually reduce the impact of additives, so we can actually eliminate them, but we pay a little bit the price in terms of shelf life and durability of the product and stability of the product. I'll give you some examples. And I'd like to start with this slide. And I have already said some of the things that are written here. So what is the meaning of replacing additives? It means, for example, to reduce the activity of water by using salt, or modifying the pH by modifying some natural substances. What is weird, or maybe what is not so strange, is that today we might reduce the content of nitrates and nitrites in meat-based products or in sausages by reducing the water of the system, water activity of the system. But reducing water activity implies either to reduce water, something that is only partially possible during the seasoning, or by adding salt. And this is an example that shows us that the replacement of the nitrates is in contrast with the current trends vis-à-vis nutritional factors, so low salt content, low sugar content. So you see that replacing is not that immediate and easy. Another example, historically, up to 50, 60 years ago, artisanal production of cured and sausages actually foresaw the content of salt, the use of salt, but this was not able to guarantee the absolute stability of the product, because these were traditional practices, and so there was no perception of the real stability of the product. So after some cases, important cases of food intoxication and so on, legislation decided to include the use of some additives for these specific products, the cold cuts, as I was saying. The other paradox is to try to have fresh products, but with 2-month shelf life. We have plenty of products on the market, and the increase in the number of products can be actually measured with the increase of linear meters of development of some areas of the supermarket with deep frozen products and frozen products. You see in supermarkets, so first dishes, second dishes, ethnical dishes. So all these products are the industrial transformation of a domestic and fresh product. In this sense, it is quite difficult to be able to describe and to find the documents needed to understand the way these products are created and prepared, because in this way we are trying to make mechanical what used to be manual in the preparation of the food. And so on one hand, I have tortellini, ravioli, for example, and so on and so forth. So they have the appealing of being fresh, but they can last 2 months. And I can have this 2 months shelf life because of different reasons. So by combining different technologies, mild technologies, by having this mild pasteurization process, the use of modified atmospheres, the use maybe of a process before the pasteurization, and then the freezing of the product allow me to have this shelf life. And maybe we are now a little bit on the edge because the stability of this product is the consequence of a set of treatments that should be well known, well managed, and well measured. So there is the need to have professional expertise and knowledge of the process in details and very precise. Sometimes it happens that for this kind of products we can have some problems related to the preservation, maybe the presence of mold for fresh pasta, or other cases more delicate, or allow me to say a little bit more dangerous, with the presence of some bacteria in the cooking preparation. And you know better than me that it is a little bit complicated to manage all these aspects. You really need to be trained, well trained. So in such a delicate system, the presence of some additives has an enhancing role because it gives the possibility to stop the products and to preserve the products. But some additives that can be easily eliminated, other additives are more difficult to substitute, so to say. Sulfur dioxide for food industry has the same role of aspirin for human beings, so it can work for plenty of things. Antioxidant, it stabilizes the color, it has a mild antibacterial effect, and so on and so forth. In some cases, and sorry if I'm also talking about things that are not strongly related to meat, for wine, for peanuts, walnuts, and so on. We know that, for example, if we want to produce wine in an inert atmosphere with no CO2, so this process allows us to reduce the content of sulfur dioxide. But in some situations, such as the use of sulfur dioxide to maintain the color for shellfish, then we see that in this case sulfur dioxide doesn't allow the color to change, but then you know that when you put it in the boiling water, so shellfish will regain their color. So we have all these aspects to take into consideration. In the most delicate case, so when we remove substances that have a specific antimicrobial activity and function, so today we have some treatments that are conventional, such as pasteurization that we all know, but others that are maybe less conventional and less known. For example, omic treatments, radio frequency treatments, high pressure treatments that I'm going to show you. My apologies. To then go into details of some of these aspects. But we do not just use nitrates and sulfur dioxide. We have plenty of additives with different functions, sometimes only aesthetic functions related to the coloring, but sometimes they are connected to functions that have become more and more important in the new products. Let's think, for example, about dressing, sauces and toppings that are used for salads, for desserts, and so on, just to get to some features, such as, for example, the texture and the easy to dose the product, for example, ketchup. So in order to have this effect, we introduce starch, for example, hydrocolloids, and then meat-based or fish-based sauces and so on, because these elements, these thickeners, have actually a function related to the texture of the product. But this is in contrast with another necessity. So companies would like to find the good texture, but also to have the clean label. And you understand that it is not always possible to achieve these two things simultaneously. I like just to skip this part because you can read it by yourself. The main point of this part is that the replacement of an additive with a technology or with something different foresees such a planning that is necessary in the food industry. The Italian food industry derives from a huge tradition, but a huge tradition where products have been developed empirically by developing a technique, and then they have been studied and scientifically tested and optimized according to some scientific parameters. This is what I try to do with my colleagues, and we try to explain this to our students at university. So the idea is to go far away from a trial and error concept to get to a possible planning of food systems, of food products. That means to have a control and a certain quality of the process, so that the process can be under control, statistic control, and that the product and service standard can be verified step by step. So sad, I think that this can sound a little bit abstract and theoretical, but regulations, for example, on HACCP or the certification scheme, as Professor Omodei Salè were referring to, are actually follow the same direction. So the idea of planning and ensuring that a system is created in order to control the process step by step, and this implies to some checks of the quality of the product, and also the hygiene concepts and aspects, and this is in turn connected to the idea of the traceability and the tracking system. So you have to check suppliers, and you have to understand all the path followed by the products in order to get to the final consumers. If we want to talk about treatment technologies, then you know that rich markets are requiring microbiological safety, long shelf lives, ready to eat, ready to cook, so easiness. But what is the meaning of this concept? It means that I'm producing something, maybe a first or a second dish, a side dish, a mix, for example, paella. So everything that doesn't need to be furtherly cooked at home. It is enough to warm it up when you receive it home. And so the difference is on the label of the product, because some products have some labels that state you first have to cook and then you can eat it, but ready-to-eat products actually don't need to be furtherly cooked at home. And this means that during the production, some thermal treatments have been carried out, such as pasteurization or so on. And these processes have to be guaranteed so that consumers will have the opportunity to warm the product up, and that's enough. So I don't have, as a consumer, to cook the product again in order to have a safe product. And this is the same concept for raw food or cooked food without chemical treatments. These are all requirements by the market. It is also true that the industry is placing on the market high numbers of products, but we see that there is a universal law by which we have the 80-20 rule. So 80 products will disappear from the market and 20 products will remain on the market. And this is actually a marketing rule, and this is not connected to the quality of the product from the hygiene and safety point of view. So maybe this is the same ratio that we see for the turnover. So 20 new products remain on the market, 80 products will remain briefly on the market, and then they will, so to say, retreat from the market because they are not that successful. I was referring to the management of parameters, and I was talking about fresh pasta. So that concept is actually very good visualized in this image. So the hurdle technology allows us to see how some intrinsic parameters of the product or other parameters such as temperature, treatment time, water activity, pH, or the presence, for example, of preservatives. So they might present obstacles or hurdles to the development of microorganisms. Then there are other situations, such as in the first case, where the most important hurdle for the microorganisms is the water activity. And this means that for the planning, the following elements maybe are not so necessary, because if the microorganism finds the hurdle of water, so maybe antimicrobial substances won't be necessary for this specific product. Or maybe when I see that the vitality of microorganisms is so high and nothing can take them under control. And so for this reason, I'll get to a product that is not suitable to the market. So, all these combinations actually require the product itself, so low water activity, acidification that can be performed with natural substances such as lemon juice, vinegar, lactic acid, or other substances like the ones we are discussing about that can maybe be eliminated or not. But to eliminate these substances, we have to carry out plenty of combinations. So you see some that are very well known, maybe you recognize the names. Other techniques are actually tested right now in order to see if we can get to products that are very similar to fresh products, but with a longer shelf life. Okay, so I need to check the time because I want to be on time. I see there are 2-3 families that belong to non-conventional heating techniques like radio frequency, microwaves, and ohmic treatments. Microwaves are well known because they work within the electromagnetic spectrum, and they have advantages and disadvantages. Among these three techniques, ohmic treatment, microwaves, and radio frequency, I have to say that microwaves are more suitable also to work on meat-based symptoms in order to allow the production of a certain quantity of additives, because currently we see at the domestic level, but also internationally speaking, some plants are now using microwaves for the pasteurization of food products. So regardless of the fact that the product is meat-based or not, because microwaves allow the reduction or the elimination of some additives. So there are some machinery that I like to show you. For example, in these pictures, you see the pasteurizers, continuous and cabinet microwave pasteurizers. You see that they are very modern in their look. They are completely closed in this kind of cabinet because according to the working regulation, there should not be microwaves going out when we exceed a certain power. And this is the same as for domestic ovens. So we were afraid at the beginning about the use of microwaves, that this could be harmful for our health. But we can say that this is only related to the fact that microwaves were thought to be dangerous, but actually microwaves are not ionizing radiations, and so they do not generate this danger, because harmful substances are related to X-ray, beta rays, for example, and also gamma ray radiations. So I see plenty of advantages. And another thing that I like to explain better, because for years we have heard that microwaves can go outside and inside, but it's not exactly the same. Microwaves interact with salt, water, and other substances contained in food, and they can trigger the generation of warmth where I have water and other polar substances. So there is no increase in heat from inside to outside, but I have homogeneous increase in heat within the product. And this doesn't happen with traditional treatments where the heat is transferred from the source to the product, usually from outside into the inside of the product. And this is related to a set of advantages, because these can be durable treatments. Microwaves don't depend from other aspects, so processed food don't need to heat some areas of the product because microwaves interact directly with the product. And so I see a set of advantages, of course. Some of these advantages are related to the non-homogeneous distribution of the heat, of the radiation, but this was actually bypassed by the use of different systems to move the electromagnetic waves within that space. So this is actually a sector that is developing a lot, and it works very well with meat, with fish-based products, and so this allows us to reduce and also to eliminate additives of the same nature that are specifically used for that purpose. Going on, I see the thermal treatment with radio frequency. I have only a couple of minutes available, but actually this treatment is like a dielectric system, and this can be used to obtain some benefits. So the target is to obtain a rapid heating and cooling. And this is the same target for conventional treatments with air, with steam and with water. So the heating curve goes up slowly with the traditional treatments, and these can generate some damage within the heating treatment. So the elimination of proteins, the change in colors, the creation of aromas, and so on. Radio frequency, actually, and then you'll see on the slides the description of the effects, of the limits, and so on, also of this treatment. For example, for the pasteurization of fresh pasta. And another possibility is related to the omic eating, the electro eating, because these benefits from the resistance of the product. And this is a technique and a technology that is mainly used within liquid products with some solid pieces like fruit salads, sauces with some pieces inside. Sorry, Professor, we still have 3 minutes for your speech. Sorry to interrupt you. Yeah, I'd like to share with you this slide. So hyperbaric sterilization, high pressure processing, so to say. So substantially, I'd like to go directly to the drawing. This process foresees the loading of processed foods in plastic within some baskets. Inside the machine, we have a very high pressure. We are talking about 500, 800 megapascal. That allows the partial disruption of some parts of the microorganisms. This is a thermal treatment similar to pasteurization, but this doesn't benefit from heating, but it benefits from pressure. The second aspect is that products obtained through this technique, through this high pressure treatment, will then need to be refrigerated. This treatment maintains the organoleptic and qualitative features of the food, and it is very suitable for juices, fresh juices that can be treated with this technology, because this does not generate problems and contraindications that are usually connected to conventional treatments. Nowadays, we have some Italian companies that allow the treatment, high pressure treatment of some processed foods such as cold cuts, hamburger, vegan hamburgers, for example, and also other products, culinary products, such as chicken, tandoori chicken, French chicken. So all these examples also with shrimps. So among the technologies I referred to, this is the one with the highest possibilities of managing and of being used in a wide range of products, because it has the possibility to reduce additives we talked about and to increase the fact that the product can be as natural as possible. I'd like to thank you for your attention. Sorry, I had to be very, very fast. Thank you, Professor, for this wonderful snapshot of the physical treatment. If there are no questions from the audience and also from the participants connected abroad, I'd like to kindly ask Roberto Lusardi and Matteo Colaone to come on stage. And now I'd like to leave the floor to Roberto Lusardi, Business Manager Meat and Prepared Food, Italian Adriatic, Christian Hansen. So he'll talk about good bacteria, a sustainable resource to support safety and competitiveness of clean label products. So the floor is yours.
Buon pomeriggio a tutti, ai presenti.
Good afternoon to the attendees here and to the ones that have joined us remotely. I'm going to talk about food bacteria, so to say those that have to overcome the hurdles explained by Professor Barbanti, and I want to explain you why and also how to control these processes.
Come oggi possano rappresentare una soluzione sostenibile a supporto della
and they can represent a sustainable resource to support safety, competitiveness of products and clean label products. So I'm going to show you some examples of clean labels and then some prospects of development for preservative-free cold cuts.
Vediamo se scorre la presentazione. Datemi l'ok.
Just a second, I'm verifying if the slides are fine.
Sì. Sì, non so se c'è. Ok. Ecco qua. Sì, batteri buoni. La prima notizia è che esistono, per fortuna, se pensiamo che...
Good bacteria. Well, the first positive news is that there are good bacteria.
Dal momento che i batteri costituiscono il 13% della vita,
they represent 13% of our planet life and men 0.01%. So, of course, it is possible to coexist with them.
39 trilioni.
There are 39 trillion microorganisms in men, besides the billions that we eat every day through foodstuff or also through air. Good bacteria are strains.
Abbiamo circa 40.000 in collezione.
There are 40,000 strains roughly of bacteria that can develop ingredients, so they represent an important resource for us to create solutions that are used in the food industry, in the pharmaceutical industry, and in the agro industry.
Il motivo per cui hanno un impatto così significativo.
Why do they have such an important impact in the agro-food chain? We estimate that more than 1 billion people globally consume a product with one of our microorganisms. And because we apply microorganisms directly from the farming through the reaction of antibiotics in favor of probiotics, we want to increase the quality of meat, of feed. So they give an important contribution to the processing, and this is, of course, bringing in benefits for consumers. And if I remind you of the UN Global Agenda for 2030, we want to achieve healthy and sustainable farming with the improvement of the well-being of all consumers. This has to be integrated in all strategies of food companies. I'm going to show you today how bacteria can help us maintain what Professor Barbanti was saying before, so to maintain fresh and safe food with some mechanisms that are different from the ones that make use of additives, and trying to solve the problem of some pathogens, like for example Listeria monocytogenes, because consumers want to buy companies from
Vedremo come
brands they
potremo
trust.
anche provare a ridurre lo spreco
And then we will
alimentare.
try also to
Oggi si
reduce
enfatizza molto
food
il
waste.
contenitore, no?
We
Quando è
place much
fondamentale che il
emphasis
contenuto
on
sia stabile all'interno di
containers
questo
more
contenitore.
than the content, but
Quindi
it's
cercheremo di
important
capire
to
come
have
le
the
colture e
content
la loro
stable
specificità
in the container.
possa
So we will
aiutare
try
a
to
rendere
understand
i
how
cibi che vengono, di cui si richiede un contenuto di servizio sempre più
microorganism
possono
cultures can
rimanere
help us in
sul
this
banco vendita
respect,
o comunque
so
nel
that
scaffale,
food
nel
stuff
frigorifero,
can stay on the
fino
shelves
alla loro
or in a
scadenza.
refrigerator until the expiry
Infine,
date.
l'ultima parte, vedremo come queste strategie possano
And
sostenere
then I will explain you in
lo
the
sviluppo di
end
alimenti,
how
come diceva
these
il professore, se non più naturali, più
strategies
sani, nel senso
can help
cercare
us
di sviluppare
develop
delle soluzioni che
healthier
consentano di produrre cibi, di
foodstuffs.
renderli comunque
So
commercializzabili, quindi
to
renderli competitivi
produce
sul
food, to make
mercato,
this
ma
food
riducendo allo
competitive,
stesso tempo la
while
quantità
reducing at the
di
same
accattivazione.
time
Un'agenda abbastanza impegnativa.
the addition of additives.
Bene, consideriamo che quello che mangiamo oggi,
So let's
circa un
consider
terzo,
one thing.
sono
1/3
cibi
of what we
fermentati, anche di
consume
quelli
every
che
day
pensiamo
is represented
non
by
esserlo, non per
fermented
definizione.
foodstuffs. Even though
La
we wouldn't
fermentazione è
think
usata
so,
dall'uomo da tempi
fermentation is used
immemori. Prima,
by
appunto, come diceva, in modo
men
tradizionale,
since a
no?
long
Per
time.
garantire
Initially,
la
it was
tecnica.
used
Per fare cosa? Per produrre
traditionally
alimenti più
to
digeribili,
produce
più gustosi, ma
foodstuffs
soprattutto
that
più
are more
buoni,
digestible,
per
more
conservare gli
tasty, and
alimenti
that last longer,
sicuramente più
because it was
complessi di
difficult
quanto
to
non
preserve
fosse oggi. Non c'era il
foodstuffs
frigorifero,
in the
non c'era
past.
la
There was no
tecnologia di cui oggi
refrigerator, there
disponiamo
was
anche
no
nelle nostre
technology
case.
we can rely
Giusto per
on
vedere
today.
velocemente in questa
So
fotografia
very
quanti
quickly
alimenti
in this picture you
consumiamo
see
ogni
so
giorno,
many
bevande
foodstuffs
o cibi
and
solidi, il
beverage,
pane stesso, per
solid
che cosa?
foods,
Sviluppare delle
bread,
caratteristiche che
which
possono
have
essere
some
quelle
characteristics,
delle
some
quindi
flavors, some
una texture, quindi una
aromas,
struttura, un
or
colore,
even a
un
texture,
sapore,
a
fino anche a
color,
una
a
forma, pensiamo
structure,
al
or
formaggio,
even a shape.
coi buchi.
Just think of the
E
famous
quindi l'uomo
Emmental
anche
cheese.
in maniera tradizionale
And
applicava in modo a
men
volte
over the
inconsapevole
years
quella teoria degli ostacoli
have
che spiegava
applied the
molto bene
so-called
il professor
hurdle
Barbanti,
technology
e che
Professor
mi rendo conto
Barbanti was
che
explaining
frapporre
before,
comunque degli
which
ostacoli per
is
fare in modo che
putting in the way some
i cibi siano
obstacles,
sicuri,
some
siano stabili,
hurdles, so
e per
that
fare questo
food is
ovviamente quello che
safe
l'uomo
and
non ha teorizzato
stable.
prima, lo ha iniziato a fare
And
già nel 78,
Lester
deve
in
inserire nel nostro processo gli
1978
ostacoli, quindi
has
estrinseci
started to
e intrinseci,
introduce
per fare in modo appunto
extrinsic
che
and
non
intrinsic
abbiamo
obstacles
un'alterazione del prodotto,
to
soprattutto
avoid
lo sviluppo di patogeni
alterations
che
of the
possono
product
rappresentare
and the development
dei
of
rischi
pathogens
per i
that could
consumatori.
represent
Sono
a danger
processi
for
termici
consumers. So there are
che
thermal
richiedono
treatments
la
that
conservazione
of
a bassa
course
temperatura,
require the
perfezionamento,
preservation
sono
at low
si
temperature,
tratta le matrici alimentari, l'acidificazione.
and water
Questo
acidification.
è tra l'altro oggetto di dibattito,
And there is still a hot debate actually in this respect.
azotati,
And then nitrates,
dove si
nitrogen.
le colture si inseriscono,
But where do we find these
è un
microorganisms
ostacolo
here?
aggiuntivo che mettiamo
They represent an additional hurdle that we place along this list of hurdles so that
indesiderato.
we avoid the development of what is unwanted.
Ecco, quando questi batteri sono, ovviamente parliamo di batteri vivi, sono altamente
I'm
concentrati,
talking about live bacteria here, and we can call them microbial cultures.
meccanismi sinergici
There are some mechanisms, and the simple ones are the ones for competition of space.
Effetto Jameson.
It is also called the Jameson effect.
Microrganismi naturalmente competono per sopravvivere o per crescere.
Microorganisms compete to survive
specie microbiche.
to the detriment of other microorganisms. And there is the production of molecules with an inhibiting effect, like lactic acid, and also some food matrix produce peptides with specific antimicrobial actions. And finally, there is a communication called quorum sensum. It's an interaction between microbial cells to send signals for the dominance of species. And here I come to some of the specific cases of the clean label applications to support products that suffer from typical stress caused by consumers or by the market, for example, the cold cuts in particular. And I will give you an example that you probably are very familiar with. These are not deteriorated products. These are products that are subject to a stress they would not be predisposed to. So, oxidation, for example, caused also by packaging, and the green packaging in particular is another challenge we want to address, because the use of a single material is requested to achieve sustainable packaging for example, sliced cold cuts, together with other stressors like LED lighting. And this actually triggers surface oxidation, especially for cold cuts like mortadella or different types of hams. So consumers do not want to buy these products, and this has a very strong impact, negative impact in terms of sustainability, because this product is still edible, but because of some characteristics that this product has, consumers do not want to buy them. The color is altered, for example. But just consider a minimum residue of few decimals to trigger oxidations. There are microorganisms that compete actually for these minimal residues of oxygen, and they block oxidation process, and that's the result if you compare a product where the competition has occurred and a product where this competition has not occurred. And I'll give you another example. I'm talking about cooked products, so ready to eat items that consumers purchase regularly, maybe some slices of ham. Because of sterility, these products are subject to manipulation, so there is a competition that occurs, and they can be easily populated by organisms that are present in the production ecosystems. And without competition, it is not possible for them not to grow, because this is a pathogen that can contaminate production lines, among which Listeria monocytogen is. And if there is no competition, this microorganism develops. And if we include microorganisms that can compete in this environment, we can contrast the development of these microorganisms, this Listeria, for example. Or another challenge is swollen packaging that are the result of gaseous pathogens, or for example tartar. This is another example. So what's today's challenge? To try to innovate cold cuts without using additives, and while being supported by scientific evidence. So that's why I want to draw your attention to Mime for Health. This is a project organized by CSQA Parma, University of Studies of Parma, the experimental SSICA for as a research foundation, and the project aims at studying new generation microbial cultures that can produce nitric oxide, which makes the pigment more stable. The challenge is to produce cold cuts with a percentage of this oxide lower than in the traditional products. So through harder technologies and the adaptation of technologies, we can allow for these reactions to be maximized, so to reduce the risks while improving the nutritional facts and the toxicological level of these products. This is the outlook for the future, so thank you for your attention. Thank you very much to Professor Lusardi, and thank you for sharing with us the results of tartar with regards to Listeria, and this is really particularly interesting. So now I will give the floor to Professor Colaone, Business Development Manager, Italy Sealed Air. He is going to discuss sustainable packaging solutions and warranty of shelf life, new case studies. Good morning. Thank you. Thank you for your attendance, and thank you for the previous presentations. I found them really interesting. During my speech, I will refer to some concepts that have been already mentioned, and at the same time, I will also move on to packaging as focus of our attention. So, just a second, I checking if the slides can go forward. So the question I asked myself, because I'm representing here Sealed Air, and you know that it is a provider and supplier of packaging solutions for edible and non-edible products. Sealed Air is at the moment developing and putting on the market for 2021 packaging for recycle. So what is the doubt that we still have as regards a possible change or a possible transition from traditional materials, the ones that we have used for during the last few decades, to recyclable materials, or that are designed to be recyclable, and monomaterials that have been mentioned. So of course this relates to the shelf life of products. That's the reason why I have decided to give you a brief outline of the scenario in terms of recyclability, and 3 case studies that apply to real cases that we had to face in the last few years, to make you understand the results when using materials that are designed to be recyclable. In 2021, we had obtained and achieved the goal of putting on the market for the most important lines, the skin line, bags, EBTF for horizontal machines that are designed for recycling. So the RIC1 or RIC4 as categories. What is the commitment of Sealed Air by 2025, which is a quite close deadline? Sealed Air wants to have 100% of its portfolio provided with packaging designed for recycling. So to say, what we have started to develop a few years ago and that we are selling nowadays, and the new productions, the new releases for the next few years, will have to be designed to be recyclable. The target is 50% on average of recycled material and 60% coming from post-consumption recyclability. We have built some collaborations with international institutes that you will see on the next slide. And in the end, you will find also an attachment with a reference list of these institutions so that you can find more details if you need to deepen this topic. So, how to certify recyclability of products? There are actually two possible types of certification. A paper one that is called desktop certification, which is the simpler one, and it is based on a knowledge of a sample that is tested. It has cost that is more effective compared to the second type of certification, and on average, this certification requires a couple of weeks. And then there is a certification that is issued after lab tests done internally or externally, according to procedures of the APR, Association of Plastic Recyclers, or PRE, Plastic Recyclers Europe, with a higher cost and that require a lab test of materials, so the time for this certification is longer. As Sealed Air, we have decided to choose mainly the second type of certification. So we refer to labs, so to assess the materials that are destined to be recyclable. And we test samples. But there is one important point I want to make. It may sound a little bit theoretical or philosophical, but I want to stress the definition of recyclability that we share with our clients. The product must be delivered in a collection point, so the product needs to enter a chain. It can be sorted adequately according to its composition, and then that it is actually recycled or can be used to create a new product. So that goes back into the system. The first case study, so I now move to the practical part. I want to talk about shelf life packed by Cryovac Dark Fresh on tray, and it's for an English one. Of course, you can find more information in these slides. We were given raw materials by one of our clients, so a piece of rump seasoned in a bag, and we packed it with Dark Fresh on tray that you see in the picture. So it is a tray with a pre-cut film that creates a sort of skin. This is a patent of our company that we have developed with one of our partners. In the protocol, we have used the same product, the same packaging technique, but with a tray and a liner. So a multi-material tray and REC7 material. And the second tray was a tray, a PET-based material with Cryovac, so category RIC1. So one traditional solution and one solution for recyclability. Our protocol required visual color control, microbiological control, and freshen tray technology is the one that allows the 100% use of the plastic film as a skin bag, because this machine allows the creation of these liners without the typical film used in these machineries, and it is applied exactly on the tray. So it is a system that allows to use 100% of the plastics given to consumers. Here are some pictures to show you the color. On the left you find the traditional solution, and on the right the IC1 PET solution. So you see a substantial difference in terms of color. As if you look at time 9 or time 21, even though you can have a look at all the intermediate timing that are available, you can get to the first shelf life day to see the evolution of the color. In terms of microbiology, some tests were made: lactic acid bacteria, Pseudomonas bacteria, and Enterobacteriaceae. These are the families of bacteria that were assessed. There are not significant differences here, even though you find some peaks at the end of the shelf life that have reached almost unacceptable limits, but that were of course caused by a cross-contamination during the opening of the trays done in the company. And just to conclude, the shelf life parameter trend is absolutely comparable, so you can choose either the first solution or the second solution. As for the protocol that we have implemented, we have reached 14 days, so we have not exceeded this period. And if the solution is implemented by the English customer, then the level can be extended to 21 days of shelf life with the RIC7 category of material. And so with a material that is designed to be recycled. In the second case example, I want to show you the thermoretractable or shrink bags, which is quite famous as a technology. The sample chosen here is undercut Phamra round cut, and by 2021 we would like to complete the range of shrink bags designed for recycling by introducing REC4 bags both for the typical tray and for those with high and medium mechanical resistance. And this will also be applied to the cheese products. And in 2023-2025, we would like to have the whole range of bags designed for recyclability. Very shortly, shelf life of an undercut packed in bags. This is a prime and round cut with 3 different bags. One DOH typical, one with OSPC 3000 or DP 4005, and one with the EDOH barrier. In terms of color, you don't really find significant differences, but what we can state is that there is no significant difference after 40 days, no gaps unless EVOH bags. For those who know and master resins, EVOH is an hydroscopic resin, so when in contact between the two bags, the performance is lower than the one with PVDC. The reason being that when we are in this industry, as sealed air, we have decided to introduce this recyclable bag. We have made some shelf life tests that have always been successful. But of course, we want to show you these differences that exist and that can dispel the doubt if a transition from PVDC to EVOH is painless as a transition. The last 30 seconds to give you another example. This is an interesting example of shrink bag BDF, which is available today for recyclability. And we have taken one typical ham pack in BDF standard and BDF recycle ready. And we have seen no difference in terms of color, neither in terms of microbiological evolution. Well, I would say that the first was even better, but what we could observe is that these packs under a display light suffer from discoloration, and in the original tray, this discoloration was not visible because it was a print. I'm drawing to my conclusions. I can suggest you to have a look at the presentation later, and I have tried to sum up the key concepts in this presentation, and thank you for your attention. Thank you very much for this presentation. It was really exhaustive and practical with some concrete figures of the research you are carrying out. So thank you very much. So now the last speaker of this session. So I was a moderator, now I'm becoming speaker because I will now conclude this session with my presentation.
So the last speech is mine. I'm Erika Tirloni, and my speech has the title Reduction and Exclusion of Additives in Meat-Based Products, How Predictive Microbiology Can Favor Choices of Process. So we all know that food additives have a technological purpose in phase of processing, transformation, and stocking, but they also have an action in terms of food safety. We can classify additives as those for which a maximum amount is required, and additives that are added according to the principle of quantum satis. This doesn't mean as much as you want, but it means that you can add the needed dose in order to have the desired effect in a specific food. So in the last few years, consumers are now searching for, as the previous speakers said, food where quantity of added additives is limited, or even some products where these additives are not present. But we always have to remember that the reduction of the dosage of additives should be matched with the guarantee of the healthiness of products. And it is my task actually to be sure that this is guaranteed. For example, to guarantee that a specific product does not foster the growth of pathogens. In the last few years, we have seen some challenge tests and shelf life studies actually to guarantee food safety and to verify the safety of food. And so these two tests actually can offer very reliable answers, but on the other hand, they are very costly and Since I daily deal with these, they are time consuming. This means that in the lab we have to spend a lot of time to do this test, and we have actually to test the entire shelf life. So in the last few years, we have focused our attention on this predictive software because they have low cost. The more used can actually be downloaded for free, and on the other hand, they can actually offer very rapid answers, so instant answers and responses. Over the course of time, we don't have to forget that the regulation 2073 actually sees predictive microbiology as a tool to guarantee food safety, and so the interest towards this discipline has become higher and higher, or also for the regulators. And we have now to try to explain what is predictive microbiology. So we are talking about models, math equations that describe the microbial growth and the change of concentration of a microorganism in a food substrate. The premise is that fundamentally it is based on the fact that microbial response of growth, activation, or maintaining of the load can be replicated, and that the behavior of microorganisms can actually be represented by different models, growth models, inactivation models, models where we estimate the production of toxins, but also models of growth probability. Companies in the last few years have tried to use predictive biology, first of all by using the HACCP plans in their risk assessment, and also considering that the application of predictive microbiology plans can reduce the cost of lab analyses. But where is the real application of this in the development of new products, in the reformulation of existing products, but also in determining shelf life and safe shelf life? So we are talking about also pathogens, because there are plenty of models. We will see a couple of examples today, but actually there is a huge variety of math models. And here I have actually listed the main softwares. The one that are more used are the Seafood Spoilage and Safety Predictor, the Food Spoilage and Safety Predictor, and the Pathogen Modeling Program. But also the combined database on predictive microbiology information. They are very easy to use, and they are user-friendly, and they can be used for free. Within this concept of predictive microbiology, sometimes we can use models that are present in these softwares just to assess and evaluate if it's possible to reduce or exclude additives in the formulation of a product by checking the direct effect on the microbial growth of some microorganisms. So the example in this case is Listeria monocytogenes. As my colleagues already said, we try to see in a ready-to-eat food if the reduction of a specific additive can have an impact on the growth curve and on the growth rate of this microorganism in this specific food. So through these models, it is possible to compare the potential of growth of, for example, Listeria monocytogenes in this case, but also of other microorganisms. So we try to assess how the microorganism with a product of the same formulation but with a different amount of additives can respond to a specific substrate. Is the microorganism still able to grow? If yes, okay, but this is not the case. Or what is the rate of growth in that specific food? Here you see the a screenshot of the FSSP, the software I was referring to. There we have a model to estimate the growth of these microorganisms by inserting some inputs, so the features of the food, and then checking if the food is supporting or not the growth of this microorganism. Now you see the screenshot, or actually the screen. And there you see that it's possible to compare two types of food directly. So if we are interested in comparing one type of food to another one, maybe in one type of food we want to reduce the amount of salt or the presence of nitrates, we can directly compare these two types of food, the one I'm producing and the one that I like to reformulate for that specific additive, by seeing how the pathogen, the Listeria in this case, is able to grow differently in the two substrates. And so you see that the software requires you to fill in chemical and physical features of the food. This software is really complex, and so I need to fill in detailed features of the food, but the software is able to give us a very reliable and precise answer. And we're going to have a look at it right now. Here you see the possibilities, for example, to assess the reduction of salt, or maybe the reduction of nitrites, or of phenols, or organic acids, for example. And here you see in the practice with some examples what I mean by this. Here you see a simulation of this software with food, with some physical and chemical features that have been simulated for this example. But there we have compared the two types of food that actually were different in terms of concentration of salt. The product, the original product, where we simulated to have 5% of salt, and another product where we wanted to reduce the presence of salt to 1%. And so we would like to understand how the Listeria is behaving in these two types of food. And the software shows us the two growth curves. And as we expect, we see that the product with more salt is related to a lower growth of Listeria. And this is actually something that we already know, but the software shows us the amount, the difference. So how lower is the growth compared to a reformulated product with a lower salt concentration. So in this case, the simulation was actually carried out for 10 days, and the time is actually decided by the operator using the software. So we see that within 10 days, in the product that I like to reformulate and where I want to reduce the salt, Listeria is able to grow more rapidly. And the difference between the original product and the reformulated one is actually equal to 0.73 logarithms. So it seems to be a very low concentration, but in such a product like this one, it is important to see that in the reformulated products, we are not exceeding the 100 figure we were referring to according to the regulation 2073 for ready-to-eat products. So the softwares actually allow us to understand if a product can be reformulated, if we can reduce the amount of salt, and we see it in the following slide. The concentration of nitrites, so because there is a request for free from nitrites products and so on, and instead of having pilot studies in the companies, by using the physical and chemical features of the food, we can use this software to see the amount of salt that we can reduce, or the amount of nitrites in this case that we can reduce in order to remain within the limits set by the regulation 2073. This is another example of nitrites, and once again I share with you another example on the organic acids. There we evaluate the addition of organic acids. In this case, you see some simulations in order to understand the difference in growth potential of the Listeria. And you see in this case that if we add a high amount of organic acids, we see that naturally there is a difference. Listeria, the red line, is actually latent, constantly latent, so there are no ideal conditions to grow. There are plenty of softwares that you can use, PNP for example. And I like to share you an example related to the possibility. Sorry, I'm confusing a little bit the presentation. And so we can actually understand the growth of Clostridium perfringens during the cooling of cooked beef supplemented with salt, sodium nitrite. And so in our software, in this case PMP, you see that the inputs are a little bit more limited, but it can be suitable to understand if with this thermal profile, with this amount of salt and nitrites, the Clostridium perfringens is able to grow or not. We see the same model in another software, the Omodei. I go through it very quickly, and you find other examples of the ability to grow by the Listeria in presence of lactic acid. There are actually plenty that you can find. I just wanted to show you an overview of the most used ones and how you can apply them also in the production phase. And here you find another example of the growth potential of the perfringens according to the presence of salt and with this thermal profile for cooling. So this was just to say that predictive microbiology offers us inputs and models that can be really interesting in order to understand if it's possible to add, to reduce, to reformulate our products. But of course, there is one limitation, so the need to have homogeneous products, to have features and inputs, chemical and physical characteristics of the product that are quite homogeneous, quite similar, quite standardized. And so softwares like these ones can just be applied to this kind of products, and it doesn't make a lot of sense to use these softwares on artisanal products. But we see that the application for the reformulation of products is very high, so I think there is a lot that we can do with predictive microbiology, and I'd like to thank you very much for your attention. I think that we have come to the end of this afternoon together. In this afternoon, we have touched plenty of topics related to additives. We talked about good bacteria, we talked about packaging, we talked about physical treatments, and also certifications. And last but not least, we talked about predictive microbiology. So I like to thank participants here in presence and also connected remotely. And I remind you that presentations will be available if you log in to the websites within today. If you have questions, we are here online and in presence to answer them. In case you have questions, curiosity, we are here available. Otherwise, you have our contact details in the presentation and you can contact us directly. Thank you very much for your attention and for staying with us.